right, so continuing on with our solution to homework number 6. This is as yet another pipe in the U-Hart basement is secured to a wall with a cable BC that has a tension at 275 pounds. The dimensions are 7 feet by 2.5 feet by 4.2 feet. Determine the equivalent moment in foot pounds at A due to the cable using the cross product, right? So answer using unit vectors I, J, and K. Okay, so when asked to use the cross product of these problems, you must use show the determinative matrix. We should have seen it anyway. But let's go on to problem Kraige. And this is sheet 3. And I am Dr. Deal. And I'm wearing a funny hat. Spring 21. Gotta remember what year it is, what semester. These are like the minimums, right? You need to remember these types of things. Homework 6, problem 3. And let's draw this thing up a little bit. Okay, so we got this like pipe. Let's just start over. So it's going to be upwards this way, and I'll have my ZX coming this way, and we can extend our X-axis here. So here's X, and this is B, and this is A here at the wall, which will make it look like it's stuck there. Okay, and this is the Z direction. Here's the X direction. Here's the Y direction, and then continuing over here in the Z direction, over in the negative Z direction, somewhere up here. Let's see, we'll make him parallel to that. Make him parallel over to here. Boom. All right. So we have some kind of connection that goes up over to there, and this is C, and it is located at right here of YAC. Right, I decided it goes from A to C in the Y direction. Okay, and then from over to here, we go ZAC, and then from here to here, and like, there's going to probably be some instructors, at least for some of you, they're going to insist that you do all these things. There's going to be instructors that don't insist on these things. But there will be some who do insist in your engineering classes that you're going to have to write all these things out. All right, so I want to try to get you on the right track, but I'm not going to babysit you into doing it. So given, we're going to say the tension, I'm not going to give it allowance. This tension is 275 pounds in between B and C there. The dimensions are XAB, and that's going to be 7 feet. YAC is 2.5 feet, and then ZAC is going to be 4.2 feet. And find M about A. Moment about A. And this time it's the equivalent moment. Remembering this, instead of as opposed to reaction moment, right? If we want to find the reaction moment, we're going to make sure we're explicit about that because they're equal and opposite to each other. Okay, so let's see. Let's write out what. First off, I'm going to need to find this this force, the tension in this force. So in order to do that, I need to get the position vector of C with respect to B. So in the x direction, that's going to go a negative 7 feet, right? And in the I, and then in the y direction, that's going to be going upwards, so that's going to be plus, so that's up 2.5 feet, J. And then in the z direction, it's going to go a negative 4.2 feet. And I don't even know if this problem's going to work out well, by the way. Don't know. We'll see. So anyway, these are feet. The magnitude of this is needed. 7 squared plus 2.5 squared plus 4.2 squared. All right, so let's write that out. I'll put the calculator down, not because you're going to need this, but just if you happen to be watching this in real time. 8.538. You don't want to see it off camera, right? You want to look and see the original thing. So now, if we want to get this force that's at BC, I'll just say BC. Great, that's the tension right there. We get our 275 times our negative 7 divided by our 8.538. This is I. The 275 times our 2.5 divided by our 8.538 J, and our 275 and our negative 4.2 divided by our 8.538 K, and these are going to be pounds. So now we got our force vector, and 275 7 times, and I get a negative 225.5 I, and then I get 275, 2.5 times. I'm doing a little trick right there, by the way. 80.53 J, and yeah, I think I'm gonna, nope, I don't have the thing I wanted. Never mind. I guess I have to quit. Okay, there you go. So I'm at 275, 4.2 times, and then our 8.538 divided, yes, and that's negative, so it's a negative 135.3. Okay. All right. And now we're going to take the moments. We need a position vector, but it's about A, so our position vector is actually pretty lame. B with respect to A is going to be 7 feet I. Pretty lame, huh? It's kind of a lame problem. That's all right. So we're going to have to take the moment about A is what we're trying to find. And that's going to be equal to R B with respect to A crossed with, that's supposed to be an R. It doesn't look like an R, right? It looks like an R. F B C. And therefore, we're going to cross this right here, take I, J, and K. And the unit vector is 7, 0, and 0. And then here we have a negative 225.5, an 80.53, and a negative 135.3. So let me give myself some space here. because this always takes up some room. So MA. All right, so when we go to this one, we can actually see this one's going to be 0 already, right? Because we're going to take this and we're going to do that, those things crossed each other. It's going to be 0. It's better to write it out, I think, than to skip over. So there's nothing about the I. But you know, this actually kind of makes sense, because there's nothing here that's going to make anything spin about the x-axis that's going to cause any kind of moment, right? There's nothing that has a twist right in there. So that's why that one's I. I want to make sure we put that minus in here. But yeah, it is going to matter. Okay. So now we're going to go that, cross that, and that, cross that. So we're going to take a 7 cross the negative 135.3, subtract that cross with that, with the 0 crossed 0.225 point. Is that a 3? Is that a 3? Is that a 3? Where is it? There's a 5. Yeah. So we'll see here in a second what the answer is going to look at. Let's go to the next line right here. And now we're going to cross that, and that times that, right? So we have our 7 crossed with our 80.53 right there, right? Minus our 0, I'm going to go that times that, minus 225.5, boom, K. And these are going to be in foot-pounds. And then I write this thing out. I already said 0I, right? And now this one, minus, but there's a minus right there, right? So that's going to be our 7 times 135.3, boom. And so we end up with a positive 947.1 J. And then lastly, this part, it's only that part right there. And so, and there's no minus, so that's going to be 7 times 80.53, let's say. Okay. Boom. And we get a positive 563.7 K foot-pounds. Now, here is the answer to the thing, but we should reflect on what this actually means, like what we've actually learned from this right here. Like, what's the physical meaning that's taking place in this? And so another way to do it is to go back to the free body diagram thing that we had before. So I have some scrap paper lying over here somewhere. And the free body diagram of this, like, we might like take a look at this thing, and if we're going to do this, we would say, well, we have 3 forces really coming up. We have a force coming up this direction, and that direction that are acting onto this piece, right? And as part of it, this guy causes a moment that goes like that right there, right? This is the Fy, and we take it times this distance. So it's just this component, that vertical component of this force, which we found to be we found to be 80, right? It's going up this way, is going to be multiplied by this length right there. And then we also we could find that this right here, which is the Fz, it's pointing in that direction, it's going to end up causing a moment that's going about that axis right there, right? Because it's kind of going this way right here. So it too is going to be multiplied by this length. You see that this force right here in the Fx, it doesn't cause a moment because it's going straight down the thing. It doesn't have a moment arm right there. So, and then when you get done looking at these moments right here, you can see by the right-hand rule, yeah, that's going to be a positive moment. The one that's caused by that's causing that moment right here, this, we could call it mz, that's positive. And then this guy right here, we could call him my. He too is positive, and he's caused by that fz times that length. So when you come back to this problem, you could kind of see that's where that was, right? Here was the fz times that length that was causing the y component, and you see that here's the f in the y direction right here, right, times that length, and that's causing the one about the z direction. So this is an important problem to look through, to digest when you're trying to organize your thoughts. And I did the whole thing wearing a silly hat, and how long did it take? All right, so let's come down to the problem. See here, there was just 15 minutes, right? So didn't take me an entire hour to do the homework problem. Should take you about twice the amount of time as it takes me. So maybe a 2-hour assignment. So that's all. Thank you.